Hello everyone, this is Zeenath Jaha Begum from MLR Institute of Technology. We are going to discuss about the subject automata and compiler design. So in that we are going to discuss about the one of the important topic, that is finite automata with epsilon transition. In the previous session, we discussed about the conversion of non-deterministic finite automata into deterministic finite automata. And also we discussed about, before that we discussed about what is the DFA and what is the NFA. So in the today's session, we are going to discuss about the how to convert the NFA with epsilon to NFA without epsilon. So here, first of all, we need to understand what is the epsilon. So epsilon is nothing but where we don't have any transition from one state to other state. So that transition will be denoted with the symbol that is known as the epsilon. So here in this topic, we are discussing about, we are converting that the state diagram of with epsilon to without epsilon. So for conversion of the NFA with epsilon to the without epsilon, here we need to follow some 3 to 4 steps. So before that, first let us discuss about what are the transition techniques are there for the extension of NFA with epsilon to the without epsilon. So if you can see here, there are the important point is that epsilon NFA has convenient feature, that is it is going to generally when we say here it do not extend the language that can be represented, and epsilon can be written only in the non-deterministic finite automata, not in the deterministic finite automata. So here we say that both NFA as well as the epsilon NFA can be recognized with the same language. There is no difference between the language. So before understanding, like whenever we are going to have the conversation of the NFA with epsilon to the NFA without epsilon, the main important concept is that here we need to understand that what is the epsilon closure. Okay, so this is the first step which we are going to see here. What is the epsilon closure? It is very easy and very important concept whenever we are doing the conversion technique. What is the epsilon closure? Epsilon closure is nothing but for a given state x is nothing but it can be a q0, it can be a q1, it can be a capital A, so on. So x, given state x, it is a set of state which can be reached from x to the null state. That means, for example, like this, if we are going from one state to other state, so if we don't have any input symbol, then in that case we are denoting with the epsilon symbol, that is nothing but epsilon closure. Now what is the epsilon closure here? Epsilon closure is nothing but here we can be able to find here for each and every state, like when from this state to the forward state, the next coming state, is there any epsilon transition? If there is an epsilon transition, you are going to write like this, q0, q1. That means epsilon closure, E closure of q0 is q0, q1. Why q0, q1? From q0 to q1 there is an epsilon. In the same way, if we write epsilon closure of q1, so do we have anything from q1? No. In that case, simply we can write the present state. We should not leave that, we should not write any null state, right? So if we don't have any epsilon transition from that state, from the present state, we have to denote with the same state. That is nothing but that is the epsilon closure. So let us see with a simple example how to define the epsilon closure. Then we'll see with one of the example how to convert the NFA with epsilon to the NFA without epsilon. Okay. So here there is one example here it is given, that is what? Consider the following figure with the 3 states. So if you can see here, there are the 3 states. For each and every states, if you can see here, they are having with the input symbol 0 and 1, and also it has the epsilon transition, right? So now we have to find it. Now whenever we say about the epsilon move or epsilon close for a state, so we have to find for A, we have to find for B, we have to find for C. That means we should not leave any state. We have to start from the A to the end C. So now, what is the epsilon closure for A? Epsilon closure of A, if you can see the previous one, what is epsilon closure of A? So from A, it is going where epsilon closure, epsilon symbol to B, and from B where it is going C. Now what will be the epsilon close of A? It will be then, it will be A, comma B, comma C. Okay. Now in the same way, if you want to see about epsilon close of B, now just check it out. Epsilon close of B, we have to check always in the forward direction, not in the reverse direction. So when we say about the epsilon close of B, so epsilon close of B is moving to C. Is C is going to some other state? No. Then what is the epsilon close of B will be? It will be simply B comma C. In the same way, epsilon close of C. Now C, do we have any the epsilon transition from C to any other state? No. Then what we can write? We have to write simply the present state instead of writing any null state. Okay. So this is the epsilon closure of a given transition diagram. So this is the ABC for A, epsilon closure for B will be BC, and epsilon closure for C, it will be simple C. So this is very, very important that in term of the, when we discuss about in the SAQ questions or in the LAQ, so this is the important thing. So if we want to understand the conversion of epsilon with NFA with epsilon to NFA without epsilon, the first step we need to understand, that is the epsilon closure. Sometimes the question will be asked separately also, find the epsilon closure for the following transition diagram. So before learning that, we should learn what is the epsilon closure. Let us see with the example of conversion of NFA with epsilon to NFA without epsilon. So here it is given with the transition diagram with the 3 state. Initial state is Q0 and the final state is Q2. So first step, what we have to do here, first we have to find the epsilon closure for each and every state. So first one, E closure of Q0. So from Q0, do we have any epsilon transition? So if we don't have the epsilon transition, we have to write the present state, that is a Q0. So we don't have any epsilon transition, so epsilon closure of Q0, it will be Q0 itself. Now epsilon closure of Q1. So from Q1, the epsilon closure is, epsilon symbol transition is going to Q2. So epsilon closure of Q1 can write as Q1, Q2. Next, epsilon closure of Q2. So epsilon closure of Q2 is, we don't have any transition from Q2 to the other state. So we can write the present state, that is nothing but that is the Q2 itself. Now coming to the step 2 here. So here to have the transition here, the input symbol, here we have a transition, we have a formula for that. So for each and every state with the input, we have to go with the formula. So what is the formula for that? That is transition of Q0. Q0 is the present state. So for example, here we have a 3 states with a 2 input symbol. So there will be a 6 possibility. 3 into 2, 6 possibility. That is, we have to write it for transition of Q0 comma A. We have to write for transition of Q0 comma B. In the same way, Q1 of A, Q1 of B, and the same way Q2 of A, Q2 of B. We have the input symbol. Now we started from the initial state, that is a Q0. Here we are going to write with a symbol, that is a transition dash. So transition dash Q0 comma A. It will be written with the formula, that is epsilon closure of transition gap Q0 comma epsilon comma A. So first we are going to find what is the value for the Q0 comma epsilon, that is transition gap. So when we write here transition gap, so transition gap is nothing but that is denoted as the epsilon closure. So here we can see that we are going to write here epsilon closure of Q0. That what is the epsilon closure of Q naught? That is Q naught itself. So here we are writing as a Q naught itself. Now epsilon closure of Q naught. Epsilon closure of Q naught is what? Q naught. And what is here the input symbol we are having? That is A. Now transition of Q naught comma A. What is Q naught comma A? That is nothing but Q1. So for transition Q naught comma A, here we got the answer as E closure of Q1. Now what is E closure of Q1? E closure of Q1 is nothing but Q1, Q2. So the answer for transition dash Q naught comma A is Q1, Q2. Now coming to the next one here, transition dash of Q naught comma B. The same way, same formula, epsilon closure, transition gap Q naught comma epsilon. So this is completely is nothing but it is known as the epsilon closure. Next, it is denoted by the epsilon closure. So epsilon closure of Q naught. Epsilon closure of Q naught is what? Q naught itself, comma B. Transition of Q naught comma B. Transition of Q naught comma B. If you can see, is there transition of Q naught of B? No, null. So simply we are going to write as null. Now in the same way, we go it for transition of Q1 comma A. Now Q1 comma A means nothing but here the present state is Q1. So when we write here transition gap Q1 comma epsilon, that can be replaced by epsilon closure of Q1. Now epsilon closure of Q1, what is the value for epsilon closure of Q1? Q1, Q2. So here we are going to write here transition of Q1, Q2 of A. Now expand this. So how we are expanding this? By using the union symbol. That is nothing but transition of Q1 comma A union transition of Q2 comma A. So Q1 comma A, do we have any Q1 of A transition? No. Do we have Q1 of B transition? No. That is nothing but null. So null union null will be null. So in the same way, we are going to see with the Q1 comma B. That is, this is replaced by the epsilon closure of Q1. Again, what is epsilon closure of Q1? Q1, Q2. Now expand this. Transition of Q1 comma B union transition of Q2 comma B. Now transition of Q1 comma B is null and transition of Q2 comma B is Q2. So phi union Q2 will be what? It will be epsilon closure of Q2. Now what is epsilon closure of Q2? Epsilon closure of Q2 is Q2 itself. So you have to write it directly Q2. In the same way, find it for what? Transition dash of Q2 comma A. So Q2 comma A. What is Q2 epsilon closure? It's Q2. What is transition of Q2 comma A? That is nothing but phi. So the answer is phi. In the same way, find it for Q2 comma B. So epsilon closure of Q2, it's Q2. Now transition of Q2 comma B, Q2 itself. Epsilon closure of Q2 is Q2. So your answer is Q2. So you got now 6 transition without the epsilon, right? So this all those things you have to combine and you have to write into one. So we are writing in a third step. So how many transitions you got? You got 6 transitions. So the 6 transitions are represented here. Okay. So that 6 transition here we are writing in terms of the table. So this table is known as transition table. So here you can see that here we are using only 2 input symbol. We are not using the epsilon transition. So Q0 comma A is nothing but Q1 comma Q2. If we don't have any transition, simply we write what? Null. So this is what? This is the transition table for the above transition function, right? And if you can see here in the above diagram, so wherever you find Q2, that will be the final state. So here, if you can see here, we got Q0, Q1 as well as Q2. Now, by seeing this transition table, the last step is nothing but we have to go for a transition diagram. So this is the above transition diagram for the above table. So if you can see here, we got a 3 states with the 2 final states. Now you have a doubt that why Q1 is also the final state, because if you can see here, Q1 is also linked to the Q2. So in that case, we can say that if the state which is linked to the final state, even that state will become as the final state. So here we have a 2 final state for that, that is Q1 and Q2. Now if you can see here, Q0 of A is what? Q1, Q2. So one is going to Q1 and other one A is going to Q2. In the same way, Q1 of A is nothing but 5, nothing. So simply we are ignoring that in the transition diagram. In the same way, Q1 of B. What is Q1 of B? Q1 of B is nothing but Q2. So you can just represent in the diagram, Q1 is nothing but Q1 of B is nothing but Q2. In the same way, Q2 of A we don't have anything, that is a null symbol. So Q2 of B is nothing but Q2 itself. So this is the final transition diagram of NFA without epsilon. So how we are saying that without epsilon? Because here we don't have the epsilon symbol. If you see the question given there, in the question we have the epsilon. So removing the epsilon, it's nothing but NFA without epsilon, and this can be removed by using epsilon closure and by using this formula, that is transition dash of Q0 of any state, any input, either it may be a 0 or 1 or either it may be A comma B, is equal to E closure of transition gap Q0 comma epsilon comma a input symbol, either it may be a 0 or 1 or A comma B. So if we have 3 states with the 2 input symbol, it will be 3 into 2, that will be 6. If you have 4 states with the 2 input symbol, it will be 4 into 2, that will be the 8 transitions. So this is the following topic which we have covered in the today's class, that is NFA with epsilon to NFA without epsilon. Hope you understand the topic here. So in the next class, we are going to discuss about the regular expression, and also we are going to discuss about some of the problems on the regular expressions, and also we'll discuss about the how to convert the regular expression into the finite automata. Thank you.